Okay, so yeah, as we were saying, we'll be talking about StyleFlow, and first we'll be starting on what GANs is. So GAN is basically the short form of Generative Adversarial Network, where in this model there are two parts, two components. One is the generator and one is the discriminator. And the generator's task is basically to generate data, or in our case, we'll take, let's say, images of faces, let's say. So the generator's task is to make human faces without any knowledge, prior knowledge to how actually humans look like. And the discriminator's job is to distinguish if the generated image is real or fake. So yeah, like that's how the name also came in, like the generative adversarial network, because both of the components try to be better than the other. So that's why it's called. That's why it has adversarial in its name. And yeah, like they work against each other basically. Yeah, so generator is responsible for producing fake examples of data out of any raw data basically. Discriminator's job is to predict whether or not the generated image is actual image, because discriminators has all the data of a real image, like how it should look. So based on this, the generator also learns like how the discriminator is able to distinguish between the real and the fake data, and then it tries to overcome that shortcoming by improving the generated image. And yeah, so if the discriminator is like maybe it's a real image, like there's a 50% chance or above that it's a real image, then the model is completely, not completely, well, it's trained basically to generate that sort of image. So here is like the progression of how the GAN improved. In 2040, as you can see, it's just the face. There's no hair, no uh, exact expression or anything like that. And then slowly and surely, it started to improve. In 2017, it looks like the images it generate looked like they were actors and actresses from some red carpet and all. But later on, there were more models that came after this, which will come through, which generated more realistic faces. So next game is StyleGAN. Is the one second. Yeah. So StyleGAN is like the next part, of next iteration of a GAN, basically, where in GAN it only generated faces. You can't put any parameters like how it should look like, or how much style attributes should be there, like the hair, any glasses, facial hairs, the gender, the age. So you can't specify that in GANs, the traditional GAN. So StyleGAN basically overcomes that by using two images, source A and source B. So, and then basically fusing it. So here you can see, keeping the source B constant, if we change the source A, the results also change. It's basically combination of the two images. So it is an extension to GAN architecture that proposes large changes to the generator model. Traditional GAN lacks control over the style of synthetic images that are generated. StyleGAN is capable of not only generating impressively photorealistic high quality photos, but also offers control over the style. Just by, if you have two references image, like if you want to change your image into not exactly your image, but basically combining two images to produce a completely separate new image, which comprises of both the style attributes from both the images. So results from StyleGAN model was like it had lots of high quality. It generated lots of high quality faces with varying style of by level of detail, and also you can change the noise level. You can control the noise uh, to basically show how much detail you want to show in that image or not. Yeah, here's the morphing example of StyleGAN. Source A is kept constant, and source B is basically changing, and the combination is also changing as well. Now comes StyleFlow. It's how do you say, like in StyleGAN, you could use two images as inputs, and it basically combines them. So you don't have to control to change one particular image and one particular style for that image only. So in StyleFlow, you are actually able to use just one image and then change the lighting, the pose, the age, gender, expression, and like add glasses, the baldness, facial hair, anything, just using one image. So the source image is first taken, and then its projection is made using StyleGAN 2. So it basically, in the first step, it uses StyleGAN 2, the second, the advanced version of the StyleGAN, and it makes embeddings, which makes it easier for the preceding changes, sequential edits. So yeah, like as we all know, StyleGAN is a high, like it generates high quality, diverse, photorealistic images by unconditional GANs. So StyleGAN was an unconditional GANs. However, the limited the options of what can be controlled, like what sort of attributes can be controlled, like expressions and all. And this StyleFlow basically overcomes that. And also, like there have been also other methods before this, but then this one it preserves the quality of the how the input actually looked and how it would look with the changes. So yeah, like two problems that were in the previous paper, like StyleGAN 2, was that attribute condition, it didn't have attribute condition sampling and attribute control editing. We'll be coming to that, like how StyleFlow basically overcame this. So yeah, like it solved both of those problems. And yeah, like it formulates conditional exploration, like which specific conditions you need to change. And also it can be done in sequential order, like first you change the lighting, then the pose, then the expression, like that in one go. You don't have to like input the same image again and again. You can just keep on changing and undoing it. So for faces, it basically varied the camera pose, illumination variation, expression, facial hair, gender, age. And it even did for cars as well, like the color of car, the pose, like from which angle it looked from, up, down, left, right, front, back, just from one image. And even like changing a particular car into another type of car, like from SUV to sedan or a hatchback, stuff like that. So here's the method that StyleFlow used. Basically, it made use of CNF blocks. CNF blocks are, how do you explain that? Conjunctive normal form. It basically is a Boolean logic that expresses formulas as conjunction of clauses. So uh, it in one particular function of the CNF block, it basically tells uh, if the image or the data has that particular sort of attribute. So in joint reverse encoding, it basically uh, gets all the attributes that are present in the source image. And the second part is the conditional forward editing, where it adds other attributes or replaces other attributes to change the image based on what attributes need to be changed. So in the first part, you basically uh, get labels of what all are the attributes in the source image. Like it's a female looking towards the left, the lighting is coming from the left, and it's smiling, and it's how many ever years old. And for the conditional forward editing, it basically changes like changing the position to looking forward and stuff like that, like multiple attributes can be changed one at a time. So yeah, here's the result of StyleFlow. In the first one, the lighting is being changed. Second one, the yaw position, the up down position, sorry, the pitch, and the yaw, left right, and then from male to female, the gender. Also for cars, you can see the pose, rotation, color, and the type of car. So here are some of the other results that was uh, found from StyleFlow, like attribute condition sampling, where a certain attribute is entered, and then the images are basically given out. Like let's say females with glasses for the first one, then 50-year-old males with facial hair, and then smiling 5-year-old children, like this. So these are all generated only. Then there's attribute transfer. Like we use a source image, and then where all the attributes need to be transferred to. And then there are bars where you can adjust the lighting, how much it needs to be like the source image. So the light was changed, the gender was changed, the pitch, the position was changed. The age was also changed. Like, yeah. And it can be made sequentially. That's the best part. Then, like from the previous paper, we saw StyleGAN, StyleGAN 2. There's like, they made it slightly more advanced. Also, it can make non-sequential edits from one image, like changing the gender, age, pose, lighting, eyeglasses, facial hair. And sequential edits. So here the attributes and lighting can be changed with the dials. And at the lower part, it can be saved for later on. The photo to the left that is being used is actually generated after using StyleGAN embeddings, but it's generated from a real image only. Yeah, so they got the right photo from the left one after many iterations. And yeah, that's it. So any questions?
No.
Okay. So yeah, like it's a very interesting topic, this one, and it's still like there's still more and more improvements every year, every paper. So we can expect like probably in this year or in upcoming years, maybe there'll be mobile. There's a application where you can change all of this. I think like Facebook will be doing it, or probably Nvidia. But yeah, like it'll be usable by anyone at all, like by all. And yeah, so yeah, thank you for joining, everyone, and hope you have a great day.
Thank you.
Thank you, Samudra.
Yeah, thank you.